Today's topic is factor pairs. Now, you probably don't know what factor means. It is a number which divides into another number. That probably doesn't make that much sense, but you'll soon understand as we go through. So here we have some equations with missing numbers. Use the number 2, 12, and 24 to complete the fact family. So we have to put these three numbers in here and in all the blank spaces, really. So what could we put here? Something times something equals something. Well, it's a multiplication, so it's a good idea to have the large good. 2 times 12 equals 24. Yeah, if it's a multiplication, then the larger number will be here. Okay, now we've done 2 times 12 equals 24. 24 must go here. What can we change here then? Exactly, 12 times 2 equals 24. Yeah. Now we have a division, and with the multiplication, the larger number needs to be equaled. So in this case, the larger number should start here. What would be the equation here? Good. And what could we have here? If 24 divided by 12 equals 2, what could we have here? (24) divided by 2 equals 12. Okay, good. All right. Now we have 1 times 18. What does that make? 18. 2 times 9. You know your 9 times table. 2, also 18. 3 times 6. 18. Yeah. So these are factors of 18. These numbers on this side. Okay, we'll go further into that. Number 3, double 28. Now, in other words, you have to do 2 times 28. That sounds right. Let's check it out. So we've got 2 times 28. In other words, we have to add them. We can also do it like this. Maybe that way is easiest. So what's 8 plus 8? 16. And then we have here 5. There we go. 56, correct. All right. Oh, they've done it a different way. Okay, so 28 is very close to 30. Yeah? So what you could do is 2 times 30, which gives you 2 times 30 gives you 60. Yeah? 2 times 3, 6, and then you have the 0. But, of course, 30 is too much, and it's too much by 2. So then you have 2 times 2, which equals 4. So you need to do 60, take away 4. Yeah? Which also gives you 56. Okay, so that's a different way of doing this one. You can do 2 times 30, or you can do 2 times 28. Of course, it's easier to do 2 times 30 and then take 4, maybe. Right, let's move on. Okay, 56. What is a factor? Here we go. Now we're going to explain. So we have 6 counters. Its 2 rows of 3 are equal to 6. So they're saying 2 times 3 equals 6. There we go. Or 3 columns of 2 are equal to 6. In other words, 3 times 2 are 6. 2 and 3 are factors of 6. Okay? So the product is what is equaled after multiplying, and factors are the 2 numbers you have to times by one another to equal the product. Are there any other factors of 6? So what other factors of 6 can you think of? Well, how else can we make 6? 1 times what equals 6? 1 times 6, yeah? So these are the factors, 1 times 6. Yeah, 1 and 6 are factors. Are there any others? Not really. Of course, you can do the reverse, 6 times 1, but they're the only ways of making 6. Okay? Yeah, that's the one we just did. You see, it's 1 times 6. 1 row of 6 is equal to 6. 1 times 6. 6 columns of 1 are equal to 6. 6 times 1. 1 and 6 are factors of 6. The factors of 6 are 1, 2, 3, and 6. Using counters, make arrays to find all the factors of 24. So we need to find out all the numbers that go into 24. Can any of you think in your head what numbers go into 24? 6 times 4, good. So in other words, we'd have to do it like this because they want you to do an array. You'd have to do 6 this way, and then 4 going down, okay, to demonstrate 4 times 6. You might not have room to do all this, and so if you know for sure it's 4 times 6 works, then you can just write 4 times 6. Okay, so we have the numbers 4 and 6. They are factors. Yeah. Anything else? There's a few more. Good. So we can have 2 times 12 or 12 times 2, doesn't matter. Anything else? 1 times 24. Is there anything else? Okay, what about 3? How many times does 3 go into 24? Well, how many times does 3 go into 6? Yes, 8. Because 3 goes into 6 2 times, so 2 times 4 is 8 times 3. And I think with that, we've done all the numbers. So in other words, all the factors, if you list them, would be 4, 6, 2, 12, 1, 24, 8, 3. Of course, you could put them in order. Now they're doing 2 times 12. 2 and 12, so 24 again is the product. Now they're doing 3 and 8. 4 and 6. 5, no, doesn't work. Okay, so you can't have 5 times whatever. But you can have 6, but we've already done that. We've done 4 times 6, so 6 times 4. So these are all the numbers that are factors. 2 times 9, thank you. What else? 2 times 9 makes 18. Good, 3 times 6. And 6 times 3, but yeah, it's the same thing really, isn't it? These numbers are all different. These factor pairs are all different. So yeah, as they've demonstrated, they've taken that away. So the factors are 1, 2, 3, 6, 9, and 18. They're all the numbers that go into 18. Right. Oh, we're doing fractions here. 2.5 times 2 equals 5. Do you know that? Yeah? Well, I can show you how they mean it. So if you have 2 counters and half a counter, and you add another half a counter and 2, then you have 5, yes? Because if you put these together, you'll get a whole counter. Okay? This means that 2.5 is a factor of 5, right? Well, let's see. Why is it wrong? Factors have to be integers, whole numbers. Okay, so they have to be whole numbers. 2.5 is not a whole number, is it? Yeah? 3 is, but the problem is 3 doesn't divide into 5. So what are the factors of 5? No, because 2 can't... Look, they've just shown you here. 2, you have to multiply 2.5 to get 5. So 2 can't be a factor. Good, 1 times 5. 1 times 5, so 1 and 5 are the only factors of 5. 5 is what's called a prime number, which means you can only divide itself and 1 into it. Yeah, 7 is also 1. 3, 1, 2. So 1 and 5. Now I mentioned something about this. These are called prime numbers. So for 2, what are the factors? 1 and 2. Okay, right? Yeah, and 1 and 17. Okay, and finally 29. 1 and 29. Right. So these numbers, what do you notice about them when you check out their factors? Yeah, so in other words, they only have 2 factors, and that is the number 1 and their own number, the number that they are. So you have 2, 17, and 29. Let's see, okay. They all only have 2 factors. What other numbers can you find which only have 2 factors? Can you think of some other ones? Tell me some, please. 64? That's not correct. Why is 64 not correct? One time, yeah? That's right. So it's got more than 2 factors. They say what other numbers can you find with only have 2 factors? I mean, which only have 2 factors, yeah? 108? No, because that's in one of our times tables, isn't it? They ask which only have 2 factors, so only 2 numbers divide into them. Cannot be what are called prime numbers. Prime numbers are numbers which only have 2 factors because they are both even numbers. Now, apart from 2, which is the exception because it's so low, apart from 2, all even numbers cannot be a prime number because they can be divided by 2. I can divide 64 by 2, which gives me 32. Well, that already means that I have more than 2 factors. So your prime numbers cannot be an even number. No even numbers. So you can't have any even numbers to have a prime number, because if it's even, it already means you can divide the number by 2. Let's go up. So what about 1? How many factors does 1 have? Yeah, so it doesn't really fit because they say 2 factors. So, okay, we won't have 1. They've done 2. So what's the next number up? 3. Is 3 a prime number? Yes, because 3 can only be divided by 1 and 3. Yeah? What about 4? Is 4 an even number? Yes, so we can't have an even number because 4 can be divided by 2. It can be divided by 1, 4, and 2, can't it? So it's already more than 2 factors. What about 5? Is 5 a prime number? Yeah, because it's here. Yeah, we've got 5 there. What about 6? No, why can't we have 6? Exactly, so you must be able to divide it by 2, which automatically means it's got more than 2 factors. What about 7? Yeah, 7 can only be divided by 7 and 1. Now 8, you're already getting the hang of this, is an even number, so we can't have 8. What about 9? No, because 9, what numbers go into 9? 1, yeah, what else? 1, 9, and 3 go into 9, don't they? You know your 3 times table. So that's more than 2 factors. And we can't have 10. Why can't we have 10? Because it's an even number. Okay, right. 11. What about 11? Yeah, it's an odd number, and it is a prime number. Okay. Anyway, we'll leave it at that for now. Yeah, of course, there's other prime numbers, as I've shown you, 17, 29. As the numbers get bigger, it's harder to find prime numbers because, of course, there's more numbers that can go into them. But there are still some. Right, so they said here 5 to 17, 29, they're all prime numbers. However, these ones are definitely not 6, 24, and 18. 24 has quite a few numbers that go into it. There's always an even number of factors. Ah, okay. So that's true. There's 4 factors here. There's 8 factors here. There's 6 here. But I'm not sure if that's always true. For example, when we did 1, the factors were 1, which is an odd number. And then when we did 9, the factors were 1, 9, and 3. And when we said 4, the factors were 1, 2, and 4. So I'm not sure if that's quite right. But anyway, we'll see. The factors of 25 are 5 times 5. Okay, yeah. So, okay, they say 1 times and 5 times 5, right? So that gives us 4. So it's 1, 5, 5, and 25. In other words, 1, 5, and 25. There's only 3 factors. Let's see. What other numbers can you find with an odd number of factors? Ah, well, we just did some numbers. Can you remember them? What numbers did I show you which have an odd number of factors? There was 1 is a number which gives you an odd number of factors because it only has 1 as its factor. Yeah, so that's an odd number, isn't it? Then there is 4. I'll just do this because it has 1. Okay. Then there is 4 because you have 1 goes into it, 4 goes into it, and 2. Well, that's 3 factors, so that's an odd number. And the next one that we thought of was 9, because that has 1, 9, and 3. Yeah, 3 is a prime number, because 3 has 1 and 3 go into it. So that's 2. That's an even number, isn't it? Yeah? They ask, what other numbers can you find with an odd number of factors? So there's 1 here, and there's 3 and 3. So these numbers all have odd factors.